Hello guys, my name is Abhinash. Welcome to my YouTube channel. Today we are going to discuss a medium level lead code problem, that is we need to swap nodes in pairs. I'll try to explain this problem statement. Let's take or let's consider this whole thing as a linked list. So we need to implement a part of code. We need to do implementation which will results as like this. Clearly observe what we are doing here is we are moving 2 here and we are moving 1 to here. We are moving 4 to here, we are moving 3 to here, we are moving 6 to here, we are moving 5 to here. So what we are doing is we are swapping two adjacent nodes. That's it. We are just swapping two adjacent nodes, which will results like this. So this is our problem statement. They give some sample inputs. Let's go to the implementation part. I'll try to solve this thing using a recursive approach instead of going with brute force approach. It's quite optimized compared to brute force approach, but it will take off and space complexity. That is one of the backlog of using recursion. That's not a big deal since its time complexity is very well optimized compared to the brute force approach. So we are going with recursive approach only. I'll explain what is recursion, all those things, while going with while explaining the implementation. Okay, let's draw a linked list. Values, assume values. So what recursion do means we just need to swap for this part. We don't need to swap for all the nodes. We just need to do a implementation which will swap these two nodes. Rest of things recursive function will take care. That means instead of doing same thing n number of times, we just write or we just implement a function or we just do a task, and using recursive function, using function call, we can try to solve remaining tasks. Okay, that means first we need to do this thing and consider this as rest of the linked list. Okay, let's see. So how to swap these two nodes? Let's say we all know that head will be pointing at the beginning point of the linked list. What we need to do means we need to remove this connection and we need to make a connection between 3 and 1, and we need to remove this connection and we need to establish a connection between 2 and 1. That's it. That's very simple thing we can do. Rest of the implementation recursive function will take care. We don't need to do anything. Okay, let's see how to swap those two things. So steps. First step is we need to take a temporary node which will point at second position. Consider temporary node as nest. Temporary node should point at the second index. So how can we point a temporary node here? We can just say nest as head dot nest. Okay, since it is present just beside of the head, we can consider this as nest as head dot nest. And what we need to do means we need to remove this connection. We need to make a connection between nest and head, and we need to remove this connection, and we need to make a connection between head and rest of the rest of the linked list. That means, what is the next step we need to do means nest dot nest equal to head. We made connection, we established a connection between head and nest. That's half of the thing is completed. So what do we need to do next means we need to establish a connection between 1 and 3. That means, how can we establish connection? Using head dot nest equal to rest. Clearly observe, after making all these steps, how this thing will look like means 2 1 3. Nest will be here, head will be here, rest part of the linked list will be here. Okay, finally we need to return nest, since nest is at the initial point of the linked list. This is the thing we need to do. Let's try to implement. First, what do we need to do means list node nest equal to head dot nest, and then we need to make a connection between nest to head. That means nest dot nest equal to head. Okay, and then we need to make a connection between head to rest part of the linked list. That means head dot nest equal to let's say rest. Let's say that's rest. Then we need to return nest. This will be our implementation. We need to do same thing for the rest of the linked list. So we are making a function call. So what is the beginning point of rest part of the linked list? That is 3. How can we get the position of the 3? Head dot nest. We can say like that, right? Head is pointing here. Head dot nest. That means from here only rest part of the linked list is starting. That's it. This will be our function call. And then we need to give some base conditions. Let's say there are no elements, there are no nodes in the linked list. That means head equal to none. Then we need to return head, since head is null, right? Let's say there are only one element in the linked list. Then we need to return just head, since there is only one element. That's it, guys. This is the implementation part of this problem. Let's run it. This problem, like this approach, beats 100%. That means it is one of the most optimized solutions